So today we're going to be taking a look at how to do hard surface shading in Unreal. So that's going to be our session today, hard surface shading. So okay, before we get to the shading part of it, I wanted to go through what hard surface shading is and how to go about the process to get your final renders. So as you can see here on the right hand side, this is my final render. This is what we're going to try to achieve today. I'm not going to go through complete Maya setup. I'll explain to you how to get through it because we have a bit of a lack of time, but I'll go through exactly what we need to look at for any kind of a prop or any kind of an asset, which is basically hard surface. So if you see here on the left, these are all the maps that I've used, and I'll go through all of these individually once we get to that stage. So before we get to the shading itself, what you need to understand is that you have to analyze the kind of reference that or you have to go through a lot of references and understand what is the kind of output that you're trying to achieve. So if you can see here on the right hand side, this is a prop fire hydrant that somebody has textured, and it has a very clear explanation of the four different kinds of materials that they have merged together to finally come up with this output. So if you look at this, there's one rough metal, there's another rough metal, then there's a painted metal. So I guess you can call one aged and the other rusted, and then you have a conductive metal. So some of you may be wondering what a conductive material may be. So in our shading pipeline, we or in the PBR shading, in PBR shading, we have many different types of materials. Right. So if you look at this first image here, you're going to see two different types of materials in this one sphere. You can see one of them is very much driven by its color, which is orange, right? And the other one is more driven by its specularity. This is slightly more understandable in the second image. You can see how the shine of the object is what is defining what the object is, and in the other side of it, a lot of it is being defined by the color, the orange color, right? So the orange color or any material where it's primarily driven by the color or the diffuse values, you call those a dielectric material, and the material which is driven by its specularity and its shine, that's called a metallic material or a conductive material, right? So in the second image, we're just blending both of them to see what is the kind of output you get. So in hard surface shading, one of the other things that you always want to look at is opacity and refraction. So whenever you have see-through, there are two different types of see-through effects that you can produce in PBR shading. One is through opacity and the other is through refractive metals. Now, refraction is proper look development or shading, whereas I consider opacity to be more of a technicality. Now, what I mean by that is, imagine you have a tree and you want to make a lot of leaves on the tree. So instead of modeling every leaf separately, which is going to be a lot of polygons, you can just place cards and then use an opacity map to drive through the card or through the four-sided object to into a shape of a leaf, right? So you will get you'll get a result like this, where you will not see any material property there at all, but you'll be able to see through the object. Whereas when it comes to refractive materials, or materials like glass, water, and all those, you will be able to see through the object while you're still able to look at the object itself. So that's why I consider opacity to be more of a technicality in shader development, and refractive materials to be more of shading itself. So in this particular asset, we are not going to be looking at opacity or refraction. So I just wanted to bring that up anyways, because it does come under hard surface shading. So for our prop fire hydrant, the first thing that you want to do is figure out what is a kind of object that you want to make, right? What I mean by that is, if I want to make any object, I'm going to gather a lot of references. In this case, I wanted to make a fire hydrant to explain the kind of materials that you can use to create it. So what I did was I went through Google, found a lot of images, and found different properties of different materials on those images and try to implement that into my render. So this is my render. If you can see here, there's a lot of scratches around the edges. You can see that there's a painted metal. There's some sort of drips going on in a few places, and they're two different colors, right? So that is the image, or that is the render that I was trying to achieve. So before I did that, I went through a bunch of references and I started seeing through them. So the first thing that I want to make sure is the kind of colors that I want to get. So I found a lot of different types. One was yellow, one was red throughout, and then there was one with the white and red variation, which I particularly liked a lot, especially this image because I like the kind of specularity it had on it. So this is the kind of spec I tried to achieve on my object as well. So once that was done, I also wanted to find out how rust and dirt affects the fire hydrant. So if you look at this image, there's no rust and dirt, but it is a good color reference. So that's the only reason I downloaded this. So in this, you can see how rust is affecting all these fire hydrants in many different places, and you can see how dirt starts to add up in very specific places. One of the things that you want to keep in mind is you always want to create your maps according to how it would actually be affected in the real world. So once I was done, I ended up creating my maps. So I created basically three different types of maps. I'll go through them. So one of the things that you want to keep in mind is when it comes to shading, your maps are as important as anything else. In fact, in most cases, especially while starting off, your maps are more important than your shading itself, because if you have really good maps, you can go through your shading quite easily without too much of a hassle. So basically, I created three primary maps. One was the color, which had both the red and the white, along with the dirt and the scratches and all of that. And then I created a specar map, which you can see here. So in a specar map, wherever it is brighter, that is where the values are higher, and that's where your specularity is going to be rougher. And wherever it's darker, it's going to be more shiny. So that's a spec R map. Also keep in mind, if you're going to create a gloss map or a spec map, that would be the inverse of this. So the blacks would be the rough parts and the whites would be the shiny parts. That's in a gloss and a spec map, but there's a spec R map, right? And in some cases, you might also want to create a ISO metal map. In this case, I've not done that, but I've created something similar called conductive metal ISO. So I shall go through that in just a bit. So the third map which I created, which is again something I call one of the basic maps, is a displacement map. So in this case, for the presentation purpose, I have increased the contrast of this map by a whole lot so that you can see the kind of variation that's there. But in general, your map should be quite flat, where it's out at a 0.5 gray. So what you want to keep in mind while creating a bump or a disp or a z-disp or any such displacement map, your 0.5 gray value will indicate the mid, which is where your surface is already. Anything higher, it will go up, and anything lower, it will go down. So this is something you want to keep in mind. So in this case, you can see that the region where the drips are there, it's supposed to come up, and the regions where I have scratches, it's going in. I'll enlarge these images in a little while and I'll show you, but for now, just keep that in mind. So I created a bunch of ISO maps. I use the ISO maps to help create my three basic maps, but I also use some of these for my shading later on. So I merged these maps together to form my ID passes. Now this is my ID 01 and this is my ID 02. So I use this much later on once I have my renders in my comp process or compositing process to actually go ahead and make things look a little bit better. So I'll get to that in just a bit. So this is to just give you an understanding of the way I worked in Mari. So some of you may be more familiar with Substance. If that's the case, that's well and good as well. But the way I've done it is I have my mask maps over here or my isolation maps here. So my ISO rust, ISO dust spec, ISO conductive material and so on over here, which is going into my color here, spec R here, and my displacement here to create variation. And these are being written out here, right? And the ISOs are being written out here. So these are the ISOs, and these are the basic three called SpecR and DISP. These two I created it through Nuke by just merging these three and putting it into one, and merging these three and putting it into another one through shuffle copy. If anyone of you is not sure how to do that, I'll probably go through that at the end if there's some time left. So once I was done with the map, I went into the Maya bit of it. Now, one of the things that you want to keep in mind is that always your renders or your shading, you always would want to try and keep it as simple as possible. So you always want to try and keep your shading as simple as possible, because if you're running on a slightly lower end machine, it generally speeds up your process. The bigger your shading network in Maya, the more time you're going to consume in trying to render. So this is one thing you always want to keep in mind. So in this case, I could have worked around with just one material. I'll get to that when I start talking about how I did the shading itself. But I went with two separate materials for a little bit extra control, and also to show you how two different materials can be merged together, which I think is pretty important, especially in Arnold. Okay, and one of the major things that you want to keep in mind is you should always go back to your maps and edit them if you feel like something is not working out fine, rather than doing it in Maya, because that always increases the processing time. But in some cases, it always makes more sense to just do it in Maya itself. So like I said, note your renders will take longer if your shader network is bigger. So that is one important thing that you might want to take away. So once I got my render output, right? Okay, let me just go through this once before I get to the next slide. So over here, I have my color, which is coming through this file. I have my spec-R, which is coming through this file. I have two shaders. One is for the dielectric material, one is for the conductive material. I'm pretty sure none of you are able to see any of this right now, but I'll go through the Maya file, so that should help you out. And then I have a bunch of remaps here to remap my spec roughness, right? The spec roughness is what I'm using in both my specular roughness layer as well as my coat layer. I'll get to that. I'll get to what coat layer does. And once I have that, I have a mix shader here, which is mixing both my conductive and my dielectric material according to this ISO map here, that is being remapped through a multiply divide node. And at the bottom I have a displacement shader, right? So the displacement shader is being connected into the final um, mix material. So that's how displacement works. So over here, in the same file but in a different node graph, I created a setup for the ID passes. um, these were the two ID passes, ID01 and ID02, which is basically my drips, rust, and like the conductive metal, right? And the white paint, red paint, and the dust being mixed into one map, just to keep it simple, right? So those two are being driven through this using an AI utility node and AOV or comp IDs or uh, data AOVs in the render settings. I'll show you how to set that up as well. So once I got my renders, I went into Nuke. So I use Nuke for two purposes. One is to comp out my final output to make it look a little bit different. So you can not just a little bit different, you can make the whole thing yellow and green if you want. That's totally left to you. But in this case, I just want to increase a little bit of saturation in a few places, and I wanted to change a little bit of the spec value in a few places. So you can always do this in Nuke at the end with your ID nodes or your ID renders. So keep that in mind. ID renders are quite useful for this. So your ID renders can be okay. So along with the IDs, I also rendered out a bunch of different passes. I don't have that in my presentation, but I'll show you those passes in just a bit. So I render out a spec direct, I rendered out a diffuse direct and indirect, spec direct and a spec indirect, a coat direct and a coat indirect, and a beauty pass and a normal pass. So a beauty pass is what you see in the end, a mix of all the passes that you have rendered, and your normal pass is more of to check what your normals look like, or to check how your displacement is working. So both these passes haven't used it anywhere in the for the comp purpose, but I did use them to check my render throughout. So let me just tell you one more thing. Once you have gone through your nuke setup, right, you can use it for two different things. Like I said, one is to change the final comp of your output. That is one thing, to make it look beautiful in the end. The other thing is, if you want to go back to shading and make your render look better rather than doing it in nuke, you can always adjust the values in nuke, find out what kind of a change is actually working best for you, and then go back and try to emulate those changes in Maya itself. So that seems to be a very fast workaround while working at home. So I almost always do that, and I would suggest you look into it as well. It's a pretty helpful thing. So that's kind of going to conclude the presentation that I've made. We'll get to the discussion later, but for now, let's go through our Maya setup, right? So this is the fire hydrant that I'm trying to take a render of. So just a second, let me just get out my outliner. Okay, awesome. Yeah. Okay, so as you can see, there's a my mesh coming through this group here. There is absolutely nothing else in that group. Then I have a sky dome. So the HDRI, one of the things that you want to keep in mind, your look dev also depends on the kind of lights that you use. So lighting is a very important thing. So you might want to put in some time to get a good HDRI, or make a good light setup. Now, I'm not really good at making a good light setup. So generally, I do two things. One is I look for a very good HDRI to download, and I use that in a sky dome, or I use Arnold's physical sky. So if you come into Arnold, you'll have to have Arnold switched on in the plugin manager first. So it'll be called MTOA in your plugin manager. You're going to want to keep it loaded and auto loaded, so your Arnold's working fine in Maya. So also, before I get through the session, I just want to show you the versions that I'm using. This I'm currently running on Maya 2018 with the Arnold version of 3.1.2.1. So some of the features may vary from different Arnold to different one. So also, this does not come by default in Maya 2018. I think it comes with 2.2 or something like that. But that's definitely not the default. Okay. So again, getting back to the lighting, the HDRI, I picked up a good HDRI, and I have plugged it into my sphere, light sphere. To create the light sphere, all you have to do is go into Arnold, lights, and create a sky dome. So that's going to give you this dome. Once you have the dome, make sure you select the dome and click on the file and load up your HDRI. Make sure it's a .HDRI format, because that's going to give you the most accurate colors and the best output. And generally, these are pretty big files, so they'll be about 500 MB, anywhere between 200 to GB, or even more depending on how big the image is. So this is a 16K map of something like a studio light setup. So that's all that is. And if you don't want to go through this process, one of the simpler things to do is come here and go to something called physical sky. So this will give you the most easiest output. So this would be your physical sky. You can change a bunch of settings to make it look better. So you can use temperature to make it look like daytime or nighttime and all that. But I'm not really gonna get into that because that'll take a long time in itself. But might be something that you would want to check it out and go through yourself. So for this case, I'm just using the HDRI. So once I had that, I started with the shader setup. So let me just show you what I have in my materials, right? So as you can see, there's actually not too much going on here at first glance, right? I'm not going to recreate this again because it'll take a long time, but I'll go through everything that I've done. First, I ended up creating my material, the dielectric material, which is going to be driving the red paint. One second. Yeah. Okay. So, yeah. So the first thing that I did was I created the material which was going to be driving the red paint and the white paint, the main flat colors, and I plugged it in to a dielectric material. So let me do one thing. Yeah, tab AI SD. Okay, I picked up an AI standard surface, right? And I knew that I wanted to create the rust and the drips and all that. So once I had this created, because I knew it was going to be a dielectric material, I went into the presets. Okay, I do not know why I'm not getting any presets. You should by default have a preset called painted car paint, right? Not metallic car paint. You'll have something called car paint. So with car paint, I picked up. I'm not entirely sure why I'm not getting the attribute, but anyway, that's what I did. So once you do that, the weight goes down to about 0.5, and your color is going to remain the same. To you can change it to whatever you want. So I think it gives some amount of metalness, but I ended up removing most of it. So like I told, metalness is going to make your object shinier. So always keep that in mind. It's going to make your material more conductive, so that it's more specular driven than opposed to diffuse driven or color driven, right? So oh, there it is. Okay, it should show up there as well, but for some reason it's not, but you have it here anyways. So this is what I used, car paint. So as you can see, it changed it to zero point 0.5 and gave me a bunch of other values that it just set up on its own, right? So once I had this, I ended up plugging in my color map. So the simplest, there are two ways you can do that. For anybody who's super new, in color, you can click on the checker box and you can click on file. So by default, it's going to add a file on its own. And if you want to directly work in node graph, how I generally do, I look for file, file texture. So that'll give you that. Expand base color. So you can just take out color and plug it in there. So you can see that the very few attributes that are being shown on the outside here, but believe me when I say this, Arnold has a lot more going on. So select the node, right click and say show all attributes. You're going to see all the attributes that this particular shader has. So base color is something that I added in first. And once I did that, I plugged in my map here. Okay, so I'm not going to do this in render it because it takes a lot of time to do that, but I'll just go through the shader setup anyways. So after that, I picked up another file for my specular roughness. Now if you remember from the previous session, okay, I don't have that here. Yeah, if you remember from the previous session, all your black and white maps are going to drive your alpha channel, and by default in Maya, alpha channel is not enabled, so you're going to have to do that. So once you select your file and once you've imported your map here, so in this case, let's say the spec R. So once I have imported that, I double click on this and I'm going to say alpha is luminance. So what that's going to do is I'm just going to use the bright values and black values and convert it into luminance for your use. And notice how I added the out color for base color, but for specular roughness and almost all other maps, I'm going to use out alpha. And the moment I bring it into the null material here, it's going to deselect a lot of different options which I cannot use. So I'll just go and plug it into specular roughness. So I'm going to use my specular roughness map there, and I'm going to use it in another place called coat roughness. So these are the two places where I'm going to use the map, but I don't want to use the same map in both the places. So what I'm going to do for that is in Maya, almost in any version of Maya, there's a tab called utilities. Now there are a bunch of utilities in here which are going to work in many different ways. So depending on what you want to do, you might want to use many different utilities. The more you use this, the bigger your shader network is going to become, and the slower your render is going to become. So try to use as few of these as possible, but it's always good to know how these work. I don't have a lot of time to go through all of them. I'll show you the few that I generally use. So multiply and divide is one of my favorites, and contrast is another one which I really love to use at a lot of time. It's going to make my map look a lot more contrasty. And I think clamp is one of them that I use in a bunch of cases. So if a lot of you guys are used to Nuke or Mari or any such software with clamp, 1 and 0 is defined by default, whereas over here it's not. Min and max is all 0, so you might want to put in the values yourself. So there are a bunch of different nodes you might want to check out, but for right now I'm just going to use multiply and divide. So what I'm going to do is I'm going to make my map more rougher or more shinier using this. So the way that works is, now because I'm using my alpha channel, it does not connect directly. So it's expecting 1 out of 3 inputs, right? So what I'm going to do is I'm just going to plug it into input 1x. You can see that it became red here only because of one reason, that being it's only picking up the red channel. So now if I come here, hopefully you'll be able to see an update here. If not, I'll show you what it does in the render anyways. So let me increase this to say 5. So you're going to see how the entire thing became more white. So 5 is a crazy high value. You obviously don't want to do that, but 1 is by default. So if I increase this to say 1.5 or say 2, you're going to see the whole map become more brighter. And if I decrease this, you're going to see the whole map become more darker. So it's like a grade node in of sorts, right? So from its output, again, I can only take output X because I only used input X, and I'm going to plug it in there. So I'm going to control my one map to make it look in two different ways using a multiply and divide node. So you can always hit tab, multiply and divide, and you can plug it in as well. Okay, so this is one way I generally like to work with my maps. So it saves me a whole bunch of time. Okay, now once this is set up, I'm going to leave this as is. I'm going to create another AI standard surface. So in this AI standard surface, I'm going to use the same color map. Okay, I'm gonna do show all attributes so that I can see what all attributes I'm working with. You can see base color here, so I'm just gonna plug that in. It's the same color map that I'm using. And as for my specular roughness, I'm going to put up the same specular roughness and coat roughness here as well. Just one thing that you would want to make sure is the coat roughness has been used, the same node has been used in both the places. Actually, I won't put this here, sorry, my bad. That's not what I want to do. I want to just use the map coat roughness. Yeah, there it is. And I'll add in a different multiply and divide node here because I'll be controlling the coat. I'll be controlling the conductive material separately. So let me just rename this real quick. Let me call this the dielectric mat, right? And conductive mat. Okay, so I'll just leave that as is for now. Now, as for my conductive material, it's the same as car paint. Let me see if they have a preset here. uh, okay, I guess they don't. So anyways, it's the same as a car paint, but the only difference being I'll not do that. Yeah, there you go. Yeah, so Maya does this from time to time where it squashes all your nodes up. It's a little annoying and frustrating, but make sure you just space it out so you know what you're doing. Okay, so now the difference that I want to make with my conductive material is the fact that it is more metallic than the diffuse value. Okay, so I'm going to keep a metalness value of say zero point 0.8. Okay, so that looks shiny enough. I'm not gonna make any more changes to this. I'll run through my actual materials which I've created earlier because that'll be a little bit more well defined. So once I adjusted the values of my conductive material and I got a good setting, what I then did was picked up something called the AI mix shader. Now, what the mix shader does is it's going to take two materials, mix them together according to a value or according to the according to the a map that you're going to plug in. Okay, so now over here you can see the shader one. Okay, I'm not sure why I'm not able to pick it up, but one of the easiest ways you can connect is just come in here. That is that, and it's connected. There you go, shader one showed up now. I do not know why it was not showing by default. I guess it's a Arnold version issue. Well, anyways, so that's how you can connect your materials, right? Now, if you come here and if you change this value to 1, you're going to see only the dielectric. And if you change it to 0, you're only going to see the conductive material. Okay, so that's not what I want. I want in some places where the value is 1 for the conductive material to show, and in some places where it is 0 for the dielectric material to show, right? So if you look at this one ISO that I have created, I don't have it here. If you look at this ISO map that I've created, it contains white regions or values close to 1 in certain regions. So this is where you're going to see the shiny surface show up, and wherever it's black, you're going to see the conductive surface show up. I mean the dielectric surface show up. Okay, so the way I would do that is click on this. For anybody who's very new in Maya, this is how the shader network gets a little screwed up, is when you are using the node graph open, but you're going to use this drop down menu to select it. So the moment I click on this, everything gets jumbled up. So if I directly hit tab and file and set it up, it generally does not do this. So that is one thing you might want to keep in mind while working. Okay, so in this file, I'm going to plug in the ISO that I had earlier, which was ISO conductive metal, or yeah, conductive metal, right? Again, now because it's a black and white map, which I'm using which I'm using for the alpha channel, I'm going to say alpha is luminance. This is very important. You may forget it in many cases, and for some of you people who may have set up the ACS color space and all that at home, you would want to change that color space here. Because nothing is set up here, it's remaining by default as a grayed out setting, but if you have it, you can always change it here. So once this was done, I plugged in my displacement shader. To do that, I press tab, displacement shader. You don't need this, you can delete it. Make the outer output to the displacement shader and a file texture to from the out alpha to the displacement. And again, over here you want to click this on. So with that, I have my displacement setup. Right now, if at all, okay, yeah, there was one more thing that you have to do in your displacement shader itself. This is something that you always want to keep in mind. Your scale should be set to 0.5. Only then, when you plug in a map with values greater than zero point 0.5, it will increase in height, and with values lower than zero point 0.5, it will go inwards. If not, it's mainly because of this value that you're not able to see it. So that's how you set that up. So is a this is how I was explaining how I set up my shader. Now let me just go through the values ones to give you a better idea of what I've done. This I do not know when I created it. Okay, so yeah. So over here you can see that I've just remapped my values of my specar map for both my conductive and dielectric material. Now, first up, as for my dielectric material, I have a base weight of zero point 0.5. I have no metalness and no diffuse roughness whatsoever. Specular weight is at one color. I've left it at white, and the roughness is plugged into a map which is coming through a multiply divide node, where I've increased its value to zero point 0.2. Now, to decrease the brightness of the specularity, I've reduced the IOR from, I think, a default of 1.5 or something to 1.2025. Now, in the previous session, somebody was asking me if every object needs to have subsurface. Now, for this example, because it's hard surface, we are not going to use subsurface at all, so that's going to remain off. Now, with just this much, I'm going to get a pretty bland output. So let me just take a render. Maya, oh shit, that's the wrong Maya, don't save. Okay, yeah, Arnold render view, there it is. Okay, so now this was the render that I'm getting. Right now, the quote is active. Let me just deactivate that. You can see that my render is missing an overall specularity. So in all places, it is, before I get to this, I have renders, AOVs and ID setups done here. Let me just walk you through that before I get to the render itself. So one last thing is the render settings. So one of the things somebody asked me from last session was what would be good render settings. So I told him that it depends on your machine and what you're trying to create. So in this case, I'm going with a vertical resolution. I mean a portrait view where it is 1920 by 1080, and with my render settings at 8 and 4 and 4. Now, because I don't use transmission SSS or volume in this particular render, I'm leaving it at default. So camera AA, every time you increase it, everything else is going to increase exponentially. This is the number you want to keep uh, always take a look at. So you can increase your camera AA, but do not increase your diffuse and your specular passes or samples by a whole lot, because that will just make your render time by increase by a whole lot. One of the other things that you want to maybe change is, by default in your filter you have something called I think Gaussian by default. You would want to change that to Caterom, so that kind of gives you a little bit better output. So that is one other thing that you want to keep in mind. And I think yeah, that's about it. Those are the only changes that I made in Arnold settings. And in the AOV settings, you have a list of AOVs on the left. Now, whatever AOV that you're going to work with, those you want to select and send it to your right. Now, these are the AOVs that I have got from the left hand side to the right hand side. N being the normal pass, to check my normals. Quote, because I'm using the quote passes. Diffuse, because I'm using the diffuse passes. And similarly specular, because I'm using the specular passes. Right? In your shader here, whatever you use, say you're going to use transmission, if at all you use your transmission, you'd want to include your transmission pass from here, mainly your direct and indirect. You can ignore the first two. They are kind of helpful, but they're just to diagnose your own renders, not to actually help with you anyway in later, right? So these are the render passes that I took from the left hand side to the right hand side. You can just select whatever you want and click it. So if I wanted transmission, I could just click on this and I'd get it here. Because I don't want it, I'm sending it back. And other than that, I created two custom setups, which is an ID01 and an ID02. The way you do that is you just click on add custom and you type in the name and you select OK, and you're going to get it here. So I named them ID1 and ID2. And if you remember from the beginning of the presentation, these were ID1 and 2. So I've created the RGB map for that. So once I had that set up, in my Hypershade, I created a file which brought in my ID2 and my ID1 maps. And once I did that, you will want to look for something called AI utility, right? So in AI utility, you want to come here and you want to, yeah, first thing you want to do is shade mode, change it to flat so that your render of the ID itself is flat. And then you can select a color map by selecting file, and you can plug in your ID map. So that's what I've done here. That is all I've done here. So once I've done this, let's say test, okay, and let me just do something. Let me remove this. Instead of this, let me put a flat, say yellow, just to see what we get. So I'll show you what the difference between normal and flat would be. So that's test. Let me get render settings here again. I'll add a custom, I'll call it test. So once test is created, I'm going to click on this and select AOV node, right? So once I do that, I'll get this here, right? Once I get this here, you should have a uh, shader. So what I've called it is test. So I'm just gonna say test, right? So now this is connected to this. Now whatever I render through this should give me a yellow ID pass. We'll get to that right about now. Okay, so that's regarding all the passes that I set up. Now once I did that, I have one camera here, which is my render cam, and I am rendering through that. You can set that up under common in render camera. Okay, so once you have that, when you hit render, you're finally going to start rendering your output. So you can see how everything is yellow here because we set up our test yellow shader to be yellow. Now we're going to use this in comp, and in comp you want to use it as an alpha channel. For that, you don't want your shadow information and all that to show up. So what you want to do for that is select your AI node and change it to from node type to flat. So that's going to give you a flat yellow. Now this is rendering the background as well. The way you switch it off is select the HDRI, and your camera visibility should be 0. For some very weird bug, it's not happening here. And this, yeah, so if you just do that, it should work. If I show you my other ID passes, you'll know what I mean. So in general, you should end up rendering a black background with RGB information in this. So if this is my a render of an ID pass, if I view the R, this is what I get, G, this is what I get, and this is what I get through B. So we'll get to that in a little while, but I just thought I wanted to clear that up. So now if you look at the passes itself, okay, so this is my beauty pass. Clear, the render takes quite some time to clear. You can always put shift and left click so that you can do a selected region render just to save some amount of time. That's quite slow. Okay, so after it renders for a while, you're going to see a good amount of spec breakup there showing up, and That's how that works. Okay, so in your normal pass, you generally use it to check your displacement. So if you can see here, the place where the drips are coming up and the scratches are going inwards, like I showed earlier in the presentation, the map has been created in such a way that the blacks will go in and the whites will come out. Point 0.5 gray will remain where the model is. So that's how our displacement map works. Yeah. Okay. So I have that set up here. I have a multiply and divide on the displacement as well to reduce the amount of contrast. I've just made it a little darker so that the displacement doesn't affect too much. So if I increase this value, the displacement is gonna increase. Now in the mix shader itself, there's nothing much happening. It's just mixing both the shaders, and this is just where the file is coming from. I'm gonna leave that as is. And yeah, I've already went through that. Okay, now for the dielectric material, let me just try something. Okay, oh, always on top, that's awesome. Now I'm just gonna keep this in the side and we're gonna be checking out the renders as we progress. Okay, so this is where I'm getting my color from. This is where I'm getting my color from. It's coming through a map, so I'm not gonna change much there. Color is gonna be the color is gonna remain as is. If I change the specular color, you can see the spec color starts to change in the render itself. I'm not going to do a whole lot of rendering. I'll just demonstrate a little bit so that you get clearish idea of what's happening. The higher the value, the brighter your spec. The lower the value, the darker your spec. So I'm not sure if my material will, yeah, so you can change it to some fancy color like red as well if you want to create some very weird looking fire hydrant, but white is good enough for now. Now with IOR, if I increase this, you can see the overall spec starts to increase everywhere, right? If I increase to say something crazy like 10, it becomes super bright, and if I decrease it to say something like 0.5, it reduces everywhere, right? Now, because the machine is not able to handle it, zero point 0.5 is looking like a whole lot. It shouldn't. Generally 1.25, that's what I'd set it up to be. Yeah, so that's the value that I ended up working with at the end. And the last value that I worked on with the dielectric material is the coat value. And in the coat value, I have a weight. Before I do that, let me switch over to my coat direct. So coat works very similar to your specularity. Now because I was using a specular roughness map and messing it up in a few places, I left along with the specularity, I used a coat to enhance the specularity a little bit so that there's an overall sheen with a different IOR value and also somewhat of a different specular roughness value. So the values work in the same way as specular roughness itself. You can change the color, you can change the weight, you can change the roughness, and also you can change the IOR values if you want. So that's it for the dielectric materials. And in the conductive material, I have a base set up with the color coming in through a map, so there's not much happening in the base except for the fact that metalness is at 0.8. Okay, and in the specular values, you have I've increased the roughness through the multiply and divide node here. And other than that, I have an IOR value set up. An isotropy, but I've left it at 0.5, but it doesn't make much of a difference. To be honest, if I leave it even at 0, you're going to see about the same render, but just the direction of the specularity itself is going to change. So that's not a whole big deal to worry about. So except for if you're working with a map, that's when anisotropy starts to affect a lot. So in your quote values, it's again very similar to specular, and from the dielectric quote values, you can change your IOR. In this case, I've almost gotten rid of the IOR. In fact, sorry about that. The weight is at 0, so none of these values are affecting at all because it's a conductive material. I didn't really need coat. It's a whole lot shiny on its own. So in the end, when these two were merging and when the mix shader was finally rendering it out, I was getting a beauty pass that looked something like this. Okay, so due to some machine problems, I'm not able to render it out fast enough and also clearly enough. And for some reason, the renders are darker, but I'll show you the renders that I've already taken out earlier with this same exact file on and I have it in Nuke. So we'll get to that in just a second. So we had the IDs set up, and then we had a normal map. Then we have the quote passes. Then we have the diffuse direct and the indirect passes, and the specular direct and indirect passes. The test is what I just created to show how an ID would work. And that's about it for the Maya part of it. Now, one of the things that happens in most cases is like right now, I'm not able to check all my renders because it takes quite a bit of time to render. So in this case, what I generally do is I'm going to set everything up, come to a decent set of values, and once I'm kind of okay with a render that I'm looking at, I'm going to stop doing a preview render. With everything set up, I'm going to launch on oh shit, no, cancel. Okay, I'm going to launch a batch render. So I'm going to go into rendering and render, and I'm going to do a batch render. For some reason, some versions of Arnold does not support batch render. It's a very weird issue. Just do a render sequence instead. You will get the same output. So the biggest reason you want to do this is to export all your render passes which you got through this. They're super helpful while trying to speed up your shading process. Now, what I mean by that is I'll get to this part of the node graph in just a bit when I explain what I've done there. But before that, let me just show you why render passes are super important. Now I have my diffuse direct and indirect pass, which is going to show me the color. I have my quote direct and indirect, which is an outer layer of specularity. And I have my specular direct and indirect, which is my first layer of specularity. So what I'm going to do is I'm going to take the diffuse direct and indirect, I'm going to merge them. So this is my diffuse direct, this is my diffuse indirect. Uh, just to give you a clear idea of what the difference between a direct pass and an indirect pass is, when the light hits the direct pass, when the light hits the object directly, that's the direct pass, and whatever light hits the object through a bounce, that becomes your indirect pass. So that's the same case for all your specularity direct and indirect and quote direct and indirect as well. So now I'm picking up the diffuse direct, indirect, merging it, and I'm going to change this to plus. Okay, yeah, plus. And once I do that, I'm going to copy this. I'm going to do the same for these two. Doesn't matter what order you put in, as in the A and B doesn't really matter. And I'm going to do the same for these two as well. So once I have these merged together, that is diffuse direct, indirect, specular direct, indirect, quote direct and quote indirect, I'm going to merge this and this with yet another add, an add function or a plus function as it's called in Nuke, and I'm going to do the same here. So in the end, the output that you see is going to be the same as your beauty output. This is your beauty output. This is the output that we just added all of these. So this is the diffuse pass, there's a specular pass added on top of it, and this is the quote pass added on top of that. So now if I check between this and this, it is exactly the same. Just to expo, so just to get a clearer idea, I'll increase the exposure of this like crazy. So this and this, right? Now if I disable this, yeah, so this and this are exactly the same. So the advantage of this is now I have all the passes being added in separately, as opposed to one beauty pass having all the passes added in and coming through a single image. So as you see here, if I put an exposure node and increase the exposure, it's the equivalent of me putting an exposure node at the end of this chain and viewing it from here. right? That's the same again. So I'm increasing the brightness of your specular direct, indirect, coat indirect, direct, and also your diffuse pass, right? Now the way this is helpful is, instead of increasing this in one place, what I can do is I can come into the diffuse pass, put an exposure here. Okay, now this is 1, this is 2. Let me put that on wipe, and now let me increase this here. I went wipe work. Yeah, there you go. Now when I increase this here, you see that only the diffuse pass is what is getting affected. It's not the specularity. Your specularity is remaining the same, but your diffuse is what is becoming bright. In fact, a better way to show that would be if I added an exposure node over my coat passes. You see how it's looking more shiny. So if you look at the overall picture, let me get rid of this and view it from here. Now if I increase this here, this exposure here, which is under my coat passes, you see the shininess is increasing, or more of the specularity through the coat is increasing. So that is okay. So that's how you are gonna set up your passes in Nuke. So once I did that, once I set it up, once I had that set up, I used my maps to break or to get rid of whatever I did not want. So only the red paint of it would get affected through this mask, and I came here and I have increased its red reds, and I've also made it slightly more brighter, so you have very specific control through these isolation as through these render passes as well. So similarly, I've used single channel ISOs or single channel masks to create masks for my spec pass. So in this case, I'm only increasing the specularity in the scratched area, and in this pass I'm only increasing the specularity or the coat in the drips area. So with that, I have changed my output from this to this. Yeah, so because it just looks a little bit better with richer saturated colors. So once that was done, I added in a constant in the background with my ID pass itself as an alpha channel, because that's how it renders by default, and I just put in a gray constant background, so there's nothing else going on here. So the way I showed the plus, this is the plus for the diffuse, this is a plus for the specular direct and specular pass, and this is the plus for the coat pass, and these are the masks that I have used. Now for anybody who is not used to Maya all that much, or comp or any of this that way, so whenever you use a mask, you always need to make sure that you have the alpha channel information, and you always want to make sure that you're in the copy section. Okay, so I think that's about it. Over here I have used a few other uh, t- uh, operations in the merge node to um, merge these together. So the way I got this red node here, and I got this dust area here, and I use a difference node to get rid of one from the other. See that? So I've used difference, minus, and minus in a few other places to set this up. So that's about it. So with that, I'm ending my session, guys.